you why you should use Baratine in a production system. It gives you journaling, it gives you consistency, gives you the ability to operate like a database. And your code is just a POJO, it's a simple Java object. You don't have to do anything fancy. So my part of the presentation is going to show you what it's like to program in Baratine, what it's like on the ground level for engineers. So, so I'll be going over the quick start for Baratine, and then I'll be going over some concepts, and I'll finish with the positioning clustering part of Baratine. So I hope the beer makes the coding more digestible. If you haven't had a beer yet, I suggest a cup or two. So first off, how do you start using Baratine? Well, you need to download it, install it, and create and deploy your very first service. And the quick start is available on the website, but I'll be doing it live, so wish me luck. So first off, we need to download Baratine. We have our own site, baratine.io. It's alpha, by the way, as you can see. Download. And there we go. Now's a good time to grab a beer, guys.
Didn't even ask for an email address.
I'm sorry?
You didn't even ask for an email address before you did the download.
Oh, yeah. That's for the beta version of the website. So it's done. Let's unzip it. So there you go. You just install Baratine. And to start it, so let's look at the directory structure first. And Sean mentioned that it's only 7 megabytes. So let's verify that. So 7 megabytes. And that's unzip. So to start Baratine, just need to say Baratine, Baratine start. Just a few seconds, and there you go. You have Baratine running. But we haven't deployed a service to Baratine, and it's not doing anything right now. So let's go ahead and do that. So let's create Maven project. Everyone here uses Maven, right? You not?
No. When you were saying it was 7 megabytes, I was joking about they can't be using Maven because their war files are so big.
Doesn't have an off check API. Ping it somehow, see if it's something.
For this alpha version, not exactly, but it will be in the beta version. Or that's a good question.
It's a culmination service.
So let's create a count service. A service that keeps count, that you can add, that you can increment and decrement. So it's nothing fancy. So we need to add the Baratine dependencies. first need to add our repository. And our dependency is io.Baratine. And we just need the APIs to deploy to compile our service. And the current version is 0.8.3, and that's alpha. Scope is provided because we just need to need for compilation.
Is there documentation on this right now, or is it just kind of by here?
On our website, we have some
Okay.
alpha documentation. But if you look at the Java docs or the source, you can download that. So, okay, let's create our counter service. So that's the open-ended version. So anything greater than. So let's delete this. So our very first counter service. Let's name it counter service. So what should a counter service do? First off, it needs to keep track of the count. Needs to be able to increment the value. Needs to be able to decrement the value. Also needs to get the count. And let's just add a general add to the counter method. So that's our counter service, but we need to tell Baratine that this is a service, so we need to annotate it and say that it's publicly accessible and by this URL. There we go. We have our very first service. So what's next? Next is we need to deploy a service. So let's go ahead and do that. Actually, we need to compile first. So we include. Great. There's no errors, so let's go ahead and deploy this jar to Baratine. And everything's done on the command line, so let's go ahead and do that using the deploy command. So there we go. Our service is now deployed to Baratine, and this service can be accessed from Java clients, WebSockets, and from HTTP. So let's test that service. Default port is 8085. Yes. And this is our naming convention. And the name of the service, which is counter. And the method name. Increment and get. Get.
Everything is private, by the way, I notice from user.
Yeah.
Yes, the service methods have to be public.
It was like magic.
It's gonna be magic, but not now, not now. So let's compile that.
You still have private on wall.
Still have the gap.
Let's fix
Yeah,
that.
that's the scammers.
Let's compile again.
You still have one private.
This is turned up for me.
Oh, this is good. Public, 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 public. Okay, that's good. So let's deploy our service again. You need to shut down the service. You need service running to be able to deploy because it stores it in our cluster file system. It's kind of like the Hadoop file system, HDFS. It's well, we can talk about that later. So let's start our service. So hopefully this time it should work. Here you go, our very first counter service. Let's call a different method. Get.
Is this returning JSON payload?
It's JSON.
But
For-
why does it put parentheses?
Parentheses.
Can you just look at the read the source?
So
Yeah, it's still returning only parentheses 39 close
it's
parentheses.
square brackets.
Or
so
square
that-
brackets,
That's,
yeah.
That's JSON to be valid.
No, but this array notation comes with the square brackets in the JSON.
Yes, to be valid JSON it has to be surrounded by curly braces or square brackets.
So it's a one element array.
Yes.
Yeah. So for it to be an object, you need to collect it.
If you return an object, it will serialize it as an object, JSON object. So let's go back to our service. So we didn't use any synchronization because it's single threaded. Baratine manages the concurrency for you, the inbox, which is like a message queue, but more efficient. So what happens when we shut down the server? Anyone know? Anyone want to guess?
Serialized. It all goes no, hopefully.
Goes away. Let's start the server back up. So what was the previous count? Did anyone remember? 38. So what's going to happen?
Should be it. Okay. Or wait, no, because service shuts down, so it saves somewhere else, so it's frog back, so it should be the same.
No, it is
Universal.
starts from 1 again.
Oh, okay.
Because
Because it's still an alpha thing then, right?
There's no database yet.
So yeah, this pause, right? We did not tell Baratine to save it for us. We need to tell it to do that.
Modify.
That's right, that modify. How about get? Do we need that?
No.
It's not modifying the state of the service, so we don't need it. So let's go ahead and compile. Let's do our deploy and shut down. And start.
When you do the shutdown, what exactly is it?
It tells your service to shut down, to wind things up gracefully, and that's pretty much it.
Is there any standard calls like finalize or something like that?
There is, but not yet.
Not yet,
Oh.
gotcha.
So that's the magic going behind the scenes. So count starts again from 0. Okay, and shut down. So what should happen now?
Should persist.
Remembers.
Remembers. That's right. So there you go. The state is served is a save between restarts. So account service, go back to account service, it's atomic, single threaded, and Sean said that it's very fast. So let's prove that. So Baratine comes with our own stress test program. Give it the service name and then the method, increment and get, and give it 100 requests. So it can process 1,300 operations per second using one connection, one thread. And the JVM is warming up, so if we do it again, it'd be faster or not. So let's increase the concurrency. Let's use 10 connections. And let's use 10 threads per connection. As you can see, there's concurrency built in, even though it's single threaded. I'll show you why later, but let's go with this example. We can also call methods asynchronously, which means that we give Baratine, we don't wait for Baratine to return the value to us, we wait for it to call back to us. And let's use that. So now, using asynchronous calls, we are able to improve our performance by 5-fold.
So I assume this is still persistent data. If you go to the website, you can see giant numbers.
Yes, let's try that. So,
All right.
so you have an atomic service that's persisted and has a very simple, the class is very simple, it's just a POJO. And what Sean means by data and code being within the same JVM is that your POJO owns the data. The data is accounted. Who knows best to update the count? It's the service itself, it's the account service itself. It's not some database that you keep the count in or some key value store. It's your application logic. So Baratine combines the application layer and the data layer and the messaging layer into one piece. That's only 7 megabytes. There's no dependencies.
So it doesn't also depend on any external server, right? No Tomcat, no.
Everything's built in-house.
So everything's.
You get a file system that's like a HDFS.
Okay.
You get a messaging system. You get a queuing system. You get a key value store. Actually, a SQL database built in internally. So what's next? Go back to our dashboard. We also give you a journal.
What are the system requirements for it? Can I run this thing on a Raspberry Pi?
Sure. You just need JDKA, as long as you have JDKA, and it should be able to run. And there's also a journal annotation that makes your service more reliable. I'll talk about it in more detail later. You would want to use a journal 95% of the time, because it doesn't add that much performance hit. But it gives your service much more reliability, and you're able to perform faster in memory once you know you have a journal back in UM. So let's go back to our slides. So this is the service we just implemented. I have practice, but I still messed it up.
It's a learning experience.
It's a learning experience. So what did we just do? What did Baratine do with our service? It put an inbox in front of our service to serialize the concurrency. It gave you a journal to back up your messages so it can reliably operate in memory. Gives you an internal key, an internal SQL database that your service streams data to asynchronously, and it gives you an outbox that, well, the purpose of the inbox is to batch messages to your service. It's transparent to your service. You only method calls are called one at a time. You don't have to know about batching to take advantage of it. And we also batch the responses. And this is a self-contained Baratine service. And we also give you the usual imports, Java, Versailles, and HTTP. You call it using any, pretty much any language. But if you're using Java, then it can be typed. So why is it low latency? Why do you get concurrent performance? It's the batching. So first thing that your service does is to ask the inbox to work. Once you know you have work, then your service will be assigned a thread to process requests, and it's not blocking. The way the inbox is designed is that once the service is asked for work, it'll be given a range of indexes that it can work on without interruption. The service doesn't modify the inbox. So it's no blocking or blocking involved. It's not a queue. And once you're in a batch, you can process those method calls as fast as possible without interruption. You don't have to go back to the queue to ask for work. Within the batch, you can do them as fast as possible without going back to without the core, the CPU core, being in the operating system scheduling code, without being in the queue locking code. You're in the code that matters the most, which is your service code. So there are no pauses from here to here. Your service is running as fast as possible for one particular batch. And because it's not blocking or locking, it's very CPU cache friendly. There's only one cache miss at the top when you're asking the inbox for work. So that's why it's very fast. There's no multitasking. Your cache is very hot, and that is what the CPU likes the most, being single-threaded, having the cache as hot, and that's where you get the performance gains in Baratine. And the other aspect of batching is that you can work that for a batch you have 6 messages, right? When we increment the counter, we don't have to write every single time to the store. Since we know we have 6 messages, we can write at the very end the batch. So the most expensive operation, the write, you can execute once at the very end. You don't have to execute every single time there's a modification to your service. So there's 2 parts. Your CPU is able to operate without interruptions, second part is that you know when the batch ends, so that's when you write to disk. And Baratine gives you forms that scales very well with your with the concurrency. It starts out slower because of the overhead of the batch of the inbox, but with the batching, it becomes much more efficient. Your service becomes much more efficient as the batch size increases. And there's a special case. If your client is not HTTP, but a service within Baratine, you get much higher performance. Because if you go back to our diagram, we bash on the inbox, but we can also bash on the outbox. And because if the client is a Baratine service, we can send the batch to its inbox. So we remove any contention. There's contention on the inbox if there's a lot of messages coming in. There's no blocking. You will need to update an atomic value to know the index that is the next available. And you may have the question of why is this reliable? Why is it safe to batch? And the answer is we give you a journal and we checkpoint your data every so often, so you don't lose anything. If the server does crash, it will restore the data on the checkpoint and then replay the journal. So, for example, if the server were to crash sometime here, we will save the state, the state of the counter from here upwards, and then the journal will replay these requests in the batch. So you don't lose anything.
Is this done transparently, or do you have to set something up?
For our service, our account service we just implemented is automatic, it's transparent to you. You don't have to worry about it. So let's go back to our code. So that's it. You get journaling, you get checkpointing, you get batching, you get queuing, and it's all transparent. And you're able to call into your service from HTTP, WebSockets, Java, and pretty simple way. It's not that much.
So it journals every request coming in and it checkpoints periodically, right?
Yes. So what does this give you? Well, it gives you the ability to operate in memory safely. You know that you have the journal backing you up, so you don't have to save on every request. You can wait until Baratine tells you that it's a good time to checkpoint the data.
Question. So obviously you persisted the primitive data type, it was long. Are you able to persist the user-defined data type? If I introduce a class, are you able to maintain that information?
Yes, any Java type, it will.
It is serializable,
it was
or
anything. It will serialize it using hashes.
so it doesn't need to be tagged as serializable?
No, hashes supports any Java type. So any object, it's your data, you define it. There's no schemas, no nothing.
What about the memory footprint when you run it during runtime, because you're doing a lot of the stuff in memory? Is it going very fast?
Well, it's going very fast.
Yeah.
Our benchmark we just did, you get 100,000 processes per second, and that's atomic operations. It's being saved to disk after a batch. It's journal, so that's pretty good, 100,000 processes for a very simple service like that.
So the limitation is more with memory, not the CPU.
It's mostly CPU, because you won't have a single thread. It's also memory too. You can't store everything in memory, and you need to page through disk, and that's some overhead. So it depends. Just answer.
Did your stress test example call more than one method, or could it?
Using our client, no.
Okay.
But you can write your own client, different methods. To the Baratine is the same thing, it's just a method call.
show that you can call two methods through this. Then you could put an exception in one of the methods and then crank it up to 1,000 and see what does Baratine do if the service in the node throws an exception.
Well, you just return it back to you. Response, instead of being the counter value, it will return the exception to you.
Will it stop? I mean,
No, it won't stop. It just keep on going.
It's okay.
It will catch it for you and return that to you.
So null pointer exception catch.
It will catch it to you and return it to you.
Did you guys compare it to Vertex IO?
Verdicts, it doesn't have, it's single threaded too, but it doesn't have a database built in.
But does the serialization for you similar?
Similar,
Very
yes,
good.
but the service doesn't own its data. That's the most important part of Baratine. The service owns the data, and you have a journal that protects your data from corruption. You have to store to save your data, and everything works together. That's why we have so many pieces in Baratine, because everything has a role in the system. It's not because we want to add bullet points to Baratine. It's everyone plays a part in the system. So this is what we call operational data. Is keeping your data close to you. Don't have data in some external database. You don't have cache. You don't have consistency issues because you might have a caching layer, you might have a database layer. In Baratine, just one layer. Your service owns this data, and it's a Java object. So with Baratine, a simple service like this, you get journaling, you get checkpointing, you are able to operate like a database, pretty much. It's single threaded, it's atomic to your service because there's only one thread operating on your data at a time. Single ownership, single wire of the data, and that's Baratine.
I'm just curious, you're running it on one of these boxes where you have like multiple threads or multiple cores. What happens to the other cores? Can you actually run 7 Baratines at the same time and have the same performance?
You won't, because your operating system will schedule the threads. So one instance of Baratine will get a slice of the CPU, another instance will get a small slice. It's up to the operating system how much Baratine gets.
Right, but if you're on a multi-core system like this one, where you can actually really have multiple threads running at the same time.
So is the question how to take advantage of multiple
Right.
cores?
We have multiple resources, and the resources can be using threads available.
Does it run on Java 8?
It requires Java 8.
So Java 8 has some,
Lambdas,
yeah,
callbacks.
so if you're
You
gonna use
can
that
use
stuff, you can use more than one core in, a single thread kind of.
No, the
From your-
service only has a single thread, but there's a thread for the inbox. There's not a thread for the service. There's not a thread for the database, and so it uses multiple threads. But for your service, there's only one thread, and it's able to operate fast because it's in memory. The data is hot, and this when your service is writing to that data, so that's how it's fast. There's no synchronization required. So it seems like there's a lot of magic, right, Paul?
Yeah, excellent.
There's a lot of magic. Well, there is. So we have a service operating like a database, and there's somewhere like 15 lines of code. So there's a lot of magic going on behind the scenes. We have another type of service, and that service that is a bare bones service that is the basis of the resource service that we just implemented, the counter, and it's a singleton. There's only one instance within a JVM. A resource service, you can have multiple instances, so let's demonstrate how you take advantage of multiple cores. Let's go back to our code. And it's a resource. A resource has an address, a URL to it. So to take advantage of multiple counters, we need to give it a field. And Baratine will manage the ID for you. So you can do queries, and your service will be partitioned across cores, across multiple JVMs, across multiple machines, based on the ID and the hash of the ID. So this is how you are able to take advantage of your hardware and multiple machines. So what happens if we add that ID and change the URL? Let's try. Let's test it out. So, service not found. Since we changed the service URL, we need to give it an ID to be able to access our resource. So I want the current address with ID 111, for example. So we have, so Baratine will treat a counter and call that method. We can choose a different counter. So this is a different instance of your service counter. So it starts from 1. And if you want a different instance, you give it a different address or ID. This is Chromium, so it might be a feature. View source, that's what it is. So if you go back to our original counter with ID 111, state is still safe, it's independent. That's how you implement multiple resources. In our case, we implemented multiple counters. So, and you're able to search too, but
Was there any annotation on the ID that it is the ID that?
it could be a long or a string.
I'm saying, was there any annotation announcing the ID as your service ID?
No, it's magic.
Okay.
This ID corresponds with your field.
Oh, okay.
So we could have called it magic.
It's called magic. There, happy? So, let's go back to our slides.
How does the data storage actually look like? You mentioned before that you have something like an ATFS type of file system underneath. How do you store that stuff?
It's complicated. It's very, very next generation compared to a lot of. So if you compare it to Hadoop, or for example, Baratine with more advanced, we have our SQL database built in, and it's based on a log structured database, which means that the writes are very fast. You would think the reads are slow too, because this is a pen only. But in Baratine, we are able to optimize that to be very, very fast too. So you have pen only performance for writes, and you get very, very fast reads, because we use internally retrieve for for the database. And the database itself is also a Baratine service, so it benefits from batching and stuff.
You said the code was open source, right?
Sorry?
The code is open source.
It's GPL. GPL, so free to use it. And if you need support, you call us.
Is it version 2 or version 3? GPL.
The base version. So
Version 3 then.
version 3, yes. So okay, this is our service. It's journal, and you have multiple instances, single-threaded. It's concurrent. It's fast, very very fast. And there's also a bare bones service where you don't get all those magic. There's no add modify. There's no automatic restore from restarts. There's no automatic paging when you run out of memory. You don't stream to this. There's no automatic checkpointing. There's no automatic query support. There's no automatic partitioning. So it seems like why would anyone want to use an ad service, right? It seems like it's very, very hardcore. Well, for the record, I never visited that website. But it's nice to still be in college, right? So there's less magic, but you have more fine-grained control. You're able to control how you want to restore from restart. You're able to control what to save on the checkpoint. You save it to a file. You save it to our internal database. You save it to MySQL. You do whatever, and you can have control of the batching. So Baratine would call your service right before a batch, would call your service right after a batch. So, for example, after a batch is done, you would want to flush your data to disk, and that's how you know. That's how you're able to perform. You do a bunch of fast operations, and you do the slow operation at the very end. So it seems like it's very hard to implement a service and ad service. Well, let's see what it takes to implement a service without all the magic. So this is my very first time doing this, so if I messed up, then be patient with me.
Yeah. Be careful with the private.
Private. I will keep that in mind. So let's write a log service, a logging service. So clients will call this service to log messages. To return anything that's becoming bored. Well, so let's give our service a name. We want it to be public. So what should we do when this message is called? We can write to this right away, but that would be inefficient. So let's store it in memory. Okay, so we know that Baratine gives you an active batch that causes method when the batch is empty, when the batch is done. So now would be a good time to save the messages to disk. look at the Java docs. Please print stream. Let's use that. Any exception that happens in your method, Baratine will return that to the caller. So if your client is a Java client, you get an exception.
What would actually happen if you would put a modify in front of a mark method? Just a modify and do nothing.
This is a basic service, it's not a resource service. Baratine won't save it for you. It would be illegal to do that. But it's a good question. So we need to clear all of this. So there you go. We have a service that's very, very efficient. Suppose you have a batch size of 1,000 requests. It will only flush once. We also have a before batch. You can open the file right before the batch. There's also a on restore that's called when server is starting up. Tell your service to initialize itself. There's also a on checkpoint that Baratine calls to tell your service that now is a good time to save yourself. So let's test our service.
What is the performance difference between resource service and service?
Since you have more control, we can perform a lot faster. You don't have to, like for our counter service, at modify, it tells Baratine to save it to a store. But Baratine won't flush it. There, we'll wait until the batch is done to flush it. So the resource service is very, very, very fast because of the batching. A resource can be much faster if you're able to
Service?
regular service, yes. Can be much faster if you're able to handle the complexity. P0 is the first parameter.
Percentage-wise, if you run the same two programs?
Should be very, very similar.
Similar.
But it's up to your application.
Deploy.
That's right. Thanks.
Is it possible for you guys to on deploy, shut down, and start instead of you doing it every single time?
Not in the alpha version, but we will have that eventually. We have a bunch of commands that you can call. Actually, we have a console too. So these are the commands we have right now. Some of them look familiar to people who have used Hadoop before. So
Or Linux.
or Linux. So there we go. Our log service. We can add debugging messages, but I think I proved the point already. So let's wrap things up. So it wasn't that hard, right? But it requires you to do a lot of things yourself. If your data set doesn't fit into memory, then you need to page to the store yourself. It's not something that everyone wants to do. So that's why we have the magic resource service. And if you want to interface to a database like MySQL that's blocking, then we have an @worker service. It has a thread pool. It's not fast because it's blocking, it's multi-threaded. So this is one way of integrating to a legacy service.
When exactly is the let's say after batches called? How do you define the batch from, if you have like thousands of requests coming in, is the batch closed after the first 5 or?
Right now, it will call when the inbox is empty. When the queue is empty.
You do it after?
After your queue is empty, yes. So you have 1,000 requests. Your service will process 1,000 requests in the inbox. So right now, your inbox will be empty.
So I'm not processing anything as long as there are requests coming in, I'm not doing anything.
Messages are still coming in.
But
Right.
I'm not writing, or I'm not getting the after. I only start my after batch functionality once everything is queued up.
Yes, that's an important point. If after batch is never called, that means that your requests are coming in faster than you can process. And right now we don't limit the batch size. We just wait until the inbox is empty. But we might want to add a maximum batch size of 1,000 or 10,000. And that's something we want to add in the future. Or if your service cannot process requests fast enough, then you would partition it. You would use a resource service, give it some random ID, and it will be spread across the cluster, multiple machines. And that's built into Baratine. It's based on the URL. The URL for the count is /county, and if you append it with some ID, then it's a new service. So this diagram, this table shows you like what's the differences between types of services. I think we need to implement a worker service. Let's do that. There we go. That's our worker service. It's multi-threaded. It has a thread pool of 100. And a worker service is a gateway that you use to call into your blocking services like MySQL. And so that's how you would implement a worker service. So for a resource service, you get a lot of magic behind the scenes. It's single-threaded. You get the ability to search. You do searches. You get automatic partitioning. You get paging. You get chip porting. You get journaling. You get batching. You get everything. But sometimes you want more control over your system, and that service might fit your needs better, but you have to manage your checkpointing, your paging, partitioning, and your searches manually. It's very, very fast if you're able to handle all those issues. And then the blocking at services, well, doesn't get any of those benefits because it's multi-threaded, can block. If all the workers are taken, it would just, the request is just appear in the inbox, so it's like a message queue for your worker service. It's very slow, of course, because it's multi-threaded. And partitioning is built into Baratine. If you have a resource service with a certain ID, it will partition those resources among the cluster. So you have your auction service here, you have another instance on another machine, and you have another instance on a different machine. So your data is automatically partitioned with your service. They go hand in hand. You don't have a different partitioning scheme for your data and different partitioning scheme for your service. They are combined. And it's all based on the URL, hash of the URL.
Are there any backup nodes?
There are backup nodes. There's a master, and if you want to have 3 servers, this guy would be the secondary for this guy, and this guy would be the tertiary for this guy. So what's backed up is the inbox and the journal. That's what you need to operate reliably, and also the store. They are backed up to.
And there's a mechanism that detects node failure.
Yes, we have our zookeeper-like system that's built specifically for Baratine. We have a heartbeat system. We know which node is up, which node is the master, just like in Zookeeper.
How did you partition that? How do you set that up?
Just a resource service with an ID. Let's go back to our code. Counter service. It's partitioned on the magic, on the ID. And this entire URL
No,
is that.
I get that part, but let's say if you run it on 3 different systems, you have exactly the same code on all 3 of them.
Yes.
When you submit the request, first request that comes in, you're submitting it against the URL, right? So the first box of the URL that receives the request.
It will proxy the request to the correct server based on the hash.
And it does the partitioning internally.
It's
Does
automatic.
it knows that there are 3 other instances.
Yes, because of the heartbeat system. It knows which
So
server
you have to set up a heartbeat, or is this a broadcast?
is automatic. It's
Self-discovery.
it's like a self.
Broadcast?
It's like Zookeeper. It's how it works. It's a heartbeat system. Each server transmit metadata about itself, and if server goes down, then bartender, like Zookeeper, would know which server is down within like 30 seconds or 60 seconds, and that's how it's able to coordinate.
So how about the master goes down? Is there any re-election of the peer group leader, for example?
It uses the gossip protocol internally, but Baratine is what we use to manage the service, to know which server is down. The secondary is a hot backup. The journal and the inbox is streamed to the secondary and the tertiary. So we have 2 hot backups that you can configure later, but not in alpha. We'll be able to.
Would you typically deploy a load balancer in front of it for failover specifically?
Do you need to? Because
If a master, let's say the first master, the first URL request comes in, and this box is down, then you don't have this one to react to it, right?
but when you configure your cluster, you define which servers are in the cluster, right? and the client can use that list to round robin.
Okay, so but the client needs then be aware that there are other systems.
It needs a URL to talk to Baratine in the first place, and an address, right? And if it has a list, then it can round robin. In version 5 of next generation of version 4, version 5 will understand the topology of the system automatically.
But you said you can use it just like via a WebSocket or via HTTP request.
Yes, it's
So
just like
from a client perspective,
just-
you wouldn't necessarily have the, let's say, knowledge with their multiple instances running backend.
you need to know, at least know which servers you can connect to. It's just like Memcache.
One URL, right?
The IP is the
Or
IP.
one IP address.
If you have one IP, then yes, you might want to have a load balancer that knows all your servers. So you can have a server at 192.168, 100, and service will be counter. You have no one at 101.
Is there a way for you to discover which instances or how many instances are up and running?
You
So
can
that I
talk to-
know which one?
You can talk to Baratine, our Zookeeper system. You can ask which server is up. That's one way of doing it programmatically. So let's finish up. So the state Baratine is GPL. It's been in active development for over 2 years, so there's a lot of work and effort put into it. It's still alpha, and the website is also alpha. You can visit it, download it, and try it out yourself. So that's pretty much it. Do you guys have any questions?
How many devs do you have working on it?
We have 3 devs working on it now.
Just curious, what's the dependency to Java 8?
There are no dependencies, just that we want people to use the lambdas in Java 8. So that's why we enforce Java 8.
So, but if I have like a restricted system that only allows me Java 7 right now, could I run it?
Right now, yes. We don't restrict it, but
Your
we can.
mileage may vary.
Don't use Lambda.
If you use Lambda, you put 1 virus. So,
And also, if you're trying it out and you're interested in doing more, Nam and Sean both actually work here, so feel free to come in and just brainstorm. But just send us an email and we'll set up a time and come in and brainstorm. I mean, the nice thing, we're going to move to beta into 1.0 by the end of this year, if not sooner. But the nice thing about this part now is that if you're testing it and you're interested, we can actually work with you on your app and see how this might be able to fit in. This is something that it is becoming a very high priority for Caucho. We see this a lot of the direction of the future of our company. So we're very interested in feedback and everything.
Is it used right now in production at this point?
if you
Any outside companies, for example, using it right now? Or?
A lot of we've taken it to some of our. Caucho has clients all over. I mean, Salesforce runs on Caucho, for example. But what we've done is we've taken it to some select clients in the alpha version. They've all expressed a lot of interest, and what we've done is, if it makes sense, we're going to start playing around with them as we move into beta or 1.0. But it'll be soon. I mean, it's just we need to do more kind of cleanups, move to beta and then to 1. But this is not something that's going to be years. I mean, we're talking months, not years away.
About 3 months for beta, and
Yeah.
about 3 months after that for 1.0.
I'm just curious, how do you guys position that more in the enterprise space, or, I mean, footprint is small enough that it can run on like a mobile phone, right?
Well, the exciting thing about this is I just spent a week talking with our partners in Asia Pacific, and their eyes just opened because they run in countries like Japan and Singapore, they're all kind of very big enterprises like Matsushita or Panasonic or whatever, and their eyes open because they were, okay, our biggest problem is database-related issues, and this solves the problem. And they were looking at it, whether it was in healthcare administration systems and delivery and all sorts of processes. And my sense from the feedback is that this is going to appeal to both medium and large companies, but also to to smaller applications as well. I mean, and that's the reason that a lot of the process has been to GPL it and make it available to everyone, because we see just a lot of potential with very little downside. And also for the companies that we've met with, one of the big pluses has been what Nam did the first 24 minutes of his presentation today, is that you just get it up and it's working, that it's not going to take them weeks and weeks to develop a service that they can, you know, I was in an office last week and we had a meeting in the morning, in the afternoon they took an engineer and, you know, he was building a service within an hour. And that's kind of one of the very cool things that we intentionally built into the product.
Okay, any other questions? Thank you very much.